Alright, so let's look at number 17. Number 17 says you have some bullets. Okay, I was wondering if there was a picture, but there's not. Okay, so I have 3 bullets, and I know that they're 120 degrees apart, so that's what I tried to draw. Pointed toward the center, the guns are timed to be fired sequentially so that the bullets all collide in the center at the same time and mash into a stationary lump. 2 of the bullets have masses of 4.5 grams. The third bullet is a mass of 2.5 grams and a speed of 575. 5B1 and B2. So let's say what we know. We know M1 equals M2 equals 4.5 grams. M3 is going to have 0.025 grams, and B3 is going to be 575. And they want us to find B1 and B2. Alright. So first thing I want to do is I want to resolve these into X and Y components. So this is on the Y axis. I'm going to call this one mass 1, mass 3, mass 2. So mass 1 has a velocity on the X axis and on the Y axis. Mass 2 now, before anything is fired, everybody's sitting still. So I really could call this B2Y prime and B2X prime. And I could call this one B1X prime and B1Y prime. If this angle is 120, then this is 120. That's a 60. That makes this be 30. And this be 30. Alright, so let's see what we can do. Well, we have on the y-axis we have M1 B1 y plus M2 B2 y plus M3 B3 y equals, alright, so that whole side will be 0 because they haven't shot the bullet yet. This will be negative M3 B3 y prime plus M1 B1 1 y prime plus M2 B2 y prime. Alright, this one is negative because it's headed to the south. These are positive. I'm going to bring this over to here. So M3 B3 y prime is equal to M1 B1 y prime plus M2 B2 y prime. So M3 we know is 0.025 kilograms. Those should be kilograms and kilograms. B3y prime is 575. Now, I know these masses are equal. I know these angles are equal, so I'm pretty sure that these speeds are going to be equal. Okay, so I'm just going to say I have 2 of those. And they have the same mass, 0.025 kilograms. And it's going to be the sine of 30, B1 prime. So let's see what we have to work with. So a 0.025 times 575. Turn on this trusty little iPad and use my calculator. So 0.025 times 575 gives me 14.375 on the left-hand side. Kilogram meters per second equals, well, that times that is 0.05. 2 times 0.025 is 0.05. And I need to multiply that by the sine of 30, which I believe is a half. So I get back to 0.025 again. V1 prime. So 14.375 divided by 0.025, I get 575. Oh, you know what I did wrong? This is not 0.025. My apologies. It's 0.045. Alright, so we got to go back and fix that one now, darn it. Okay, so let's try that again. 2 times 0.045 times the sine of 30, I apologize, gives me 0.045. That makes a little more sense. Didn't make any sense for it to come out the same as the 575 for the first bullet because the masses weren't equal. So 14.375 divided by 0.045 gives me V1 prime to be 319.4. That's also V2 prime. And if we check our correct answers, it's good. Yay, I worked it. Alright, so there's 17. Let's go on to 18. 18 says Max amassed 60 kilograms, is in Boulder for the holidays, enjoying the mountain snow. He runs horizontally with a velocity of 3.8 meters per second, jumps onto a sled of 12 kilograms at rest. Find the velocity of the sled and Max as they move away first, ignoring friction. Alright, so we have Max with a mass of 60 kilograms. We have the sled. That's 12 kilograms. We have the speed of Max initially. He runs and jumps on it, moving at 3.8 meters per second. And he has no velocity for the sled initially. And then after he jumps on, the speed of Max prime is equal to the speed of the sled prime, because they're moving off together, is equal to something we don't know. So we have M Max, speed of Max, plus M sled, speed of sled, is equal to mass of Max plus mass of sled times V prime, whatever that is. So 60 times 3.8, that's all 0 because it's not moving, is equal to 72, because that's the sled and Max, V prime. Alright, are we good there? So I'm going to multiply 60 times 3.8. And I think I'm going to get 2,280, but I'm going to check it because, man, this are 228, because this morning the old brain is not working very well. So let's check it out. So 60 times 3.8 is 228, so I was right, 228 kilogram meters per second divided by 72. 72 just plain old kilograms. Gives me V prime. So divide that lovely answer by 72, and we get 3.17. So that's part A. Part B says, now that part A was with no friction. Part B says, well, he is an AP, so if the sled and he coast to a stop in 30 meters, what is the coefficient of kinetic friction between the sled and the snow? So I'm going to say, well, VF squared equals VI squared plus 2AD. He's going to come to a stop, so 0 equals 3.17 plus 2A. I'm looking for D is 30 meters. I'm going to square 3.17. And my iPad did not like that. So we're just going to go clear that. And we get about 10.04, and then we're going to move that over to the left-hand side, so we have negative 10.04 meters squared per second squared, and we're going to divide that by 60 to give us our A, 60 meters. So A is going to be negative, pretty much negative 1/6, which is about 0.166, so let's see what's going on with that. 60. 0.167, there we go, negative 0.167 meters per second squared. Now if he's brought to a stop, net F equals MA. The friction is stopping him, so friction is equal to the 72 kilograms times 9.8. Let me say that again. The acceleration was negative 0.167. So if I multiply that, I get friction to be about 12.05 newtons. Now the force normal is just going to be the weight of Max in the sled, so 72 kilograms times 9.8. So 72 times 9.8 gives me a 705.6. So mu is equal to friction over normal. So now I have 12.05 divided by 705.6. So I don't have much frictional coefficient, so 12.05 divided by 705.6 gives me coefficient of friction to be 0.017. 0.017. So that's part B. Alright, let's look at number 19. Number 19, two identical billiard balls are traveling toward each other. They experience a perfectly elastic collision. So if they experience a perfectly elastic collision, the one that was moving to the right at 7 meters per second will now move to the left at 7 meters per second. So this is before. Seven meters per second to the right. And this one was 4 meters per second to the left. So they basically swap velocities. So if they've swapped velocities, then, and this is, let this be V1, and this be V2, according to how the problem was written. Alright, so they just swap velocities, and this, they're going to call this one V2, and this one's called V1. So V1 now becomes a negative 7 meters per positive 7 meters per second, because it changes direction and gets the new velocity. So that's my V1 prime, and my V2 prime is now going to become my negative 4 meters per second. Alright, 19 is done. 20, 21, and 22 are center of mass problems. We're not going to worry about those right now. So I'll move on to the review questions.